In this video we will learn about the relationship between the elasticity of scale that we understood in the last video and the shape of the cost functions. So let's get started. Primarily we shall resort to another type of elasticity, which is the elasticity of cost, and we will calculate it. With the help of the elasticity of scale we will find its relationship with it, and then we'll be able to make understanding of the shape of the cost functions. So the elasticity of cost is simply the ratio between the relative increase in the cost to the relative increase in the output. So it tells us about the changes that will take place in the cost, how much of them in percentage terms when we increase the output. So the effect of output is to be observed on the cost, but in a proportionate way. When we try to relate it with the elasticity of scale that we have already calculated before, the elasticity of cost is actually the reciprocal of it, which means that the elasticity of cost, which is represented with E subscript C, is equal to 1 over epsilon. So the cost function, we start with it in order to develop the relationship, because it is the elasticity of scale cost. So the cost function is equal to this, the sum of the products of the prices and the quantities of the inputs involved. In this case there are two inputs, V1 and V2. Their prices are P1 and P2. So this is the simple budget constraint or cost constraint in this case, but we are considering it as a function right now. We are not considering it as a constraint where the cost is considered to be same, which is called as iso cost curve. This is simply the cost function in this case. So there is no constancy of C in this case, and you can't see any bar on C here. So the differential of cost will be equal to this, that is the differential of the variable in it, that is V1, and the other variable, that is V2, where P1 and P2 are considered as constants here, though they can vary because the prices of the inputs, for example labor and capital, they can change, but right now for the sake of simplicity we have assumed that they are fixed in this instance. dV1 and dV2 are the differentials of the two separate variables. Since it is not a functional form, it is an equation form, it is easy to write d wherever we see a variable. Now the next step is that we have brought V1 in the denominator as well as numerator, and V2 both in the denominator and the numerator. And this is no surprise because dV1 over V1 and dV2 over V2 are of some use for us, because in the returns to scale their value are considered equal to each other. Therefore we consider them the same notation, that is dV over V. For this reminder you can see the elasticity of scale video in which we did this. And then after reminding ourselves about this ratio, we can simply put this value here. As you can see, the substitution is done, and after substitution they become the same, just like they did in the elasticity of scale derivation, and now we have taken them as a common factor. The remaining value is this. And when we look at this value, it is actually the cost function that we started with, so we can write C instead of this whole expression. So this is, in other words, C. So when I consider it C, it can go into the denominator when it goes on the other side of the equation. Therefore DC is now having the denominator C, whereas the value of dV over V is the same, and it is on the right hand side. So this adjustment has helped us. We can do it stepwise. So these are the steps that we consider this as one unit, and we already know that this is equal to the cost function, and then the C was shifted to the other side where it appears in the denominator. Now we can consider this as our latest finding, in which these two values are equal. But it is not the only thing that we need, because the formula is comprising of not just this ratio, rather of this ratio as well. So the proportionate change in quantity, that is the output, is also to be involved in this expression. So we bring this term here. In other words, I am multiplying the reciprocal of this term here. The other option could be to divide instead of multiplying, because if we multiply it will be this term, but if we divide it will be the same term which is appearing in the denominator. So dividing is the natural thing, however we have multiplied it. It's up to us, we can either divide it or multiply it, but in a reciprocalized form. So when we multiply, we use this term on both sides. Definitely we have to do this, and then it can appear in the division form, and when we bring it in the division form it will be reciprocalized, and then we can see that this is the elasticity of cost formula, whereas this will be written in another way. That way will be clear as we go into the next step, but right now we just want to make sure that on the left hand side we have developed the formula of elasticity of scale. Now we focus on this part that we delayed for a moment. This is actually the reciprocal of what the elasticity of scale is. In the elasticity of scale, we remember that this was in the numerator and this was in the denominator. So if I reciprocalize it, it will be like this, that is 1 over the reciprocal of the term. So now it is in this curly bracket, this expression is actually the elasticity of scale, and therefore the relationship that we considered in the beginning is now proved, because it is now 1 over elasticity of scale, that is epsilon. So the two elasticities, the elasticity of cost and elasticity of scale, are reciprocal of each other. There is another way of writing this elasticity of cost, and for that we just need to reciprocalize the formula that it has. This is the formula, and now we convert this division into multiplication. The denominator gets reciprocalized and appears in it, and then dc over dq and q over c. What we have done is we have gathered the differential terms together, and we have written the original values separately here, because we know if we write them together, these differential terms, they will become the derivative of cost function with respect to output, which is the marginal cost. And c over q, if I bring it in the denominator, it will become c over q instead of q over c. It will be reciprocalized, and this is actually the average cost. So now it has more of economic meaning instead of this formula, because elasticity of cost can be considered as the ratio of the marginal cost function and the average cost function. This is what we have developed, another form of writing the elasticity of cost, and this is actually equal to the ratio of the marginal cost and the average cost functions. So this is the elasticity of cost. Now finally we will try to recall the elasticity of scale and the shape of the cost curve. In this case we are considering the average cost curve. It is explained here with the help of these possible values as well as the diagram. If the elasticity of scale is greater than 1, it means that doubling the output requires less than the doubling of inputs, or in other words, cost. Because when we talk about doubling the inputs, definitely their cost will also be doubled, because we'll have to spend more, that is double of what we were spending before. So in this case it is an efficient situation, because we can double the output without doubling the inputs, because elasticity of scale greater than 1 means increasing returns to scale, and therefore it is a favorable situation. And in the average cost curve, the phenomenon is that it is falling, and here you can see that the elasticity of scale is greater than 1 and the average cost curve is falling in this region. Then it comes to the other possible value of elasticity of scale, which is 1, and in this case we remember from the topic of elasticity of scale that it is constant returns to scale, and in constant returns to scale We can double the output simply by doubling the inputs. In other words, the cost will also be doubled. In that situation, we have a constant AC, that is this point where the cost is constant, or it is at its minimum. The average cost minimum point is taking place at this point. Now the final option is that the elasticity of scale, or epsilon, has a value less than 1. It means that we have a decreasing returns to scale, which is an unfavorable situation where if we want to double the output, we have to double the more than the double of the inputs. It means that the cost would be more than the double that we have been doing before. It is an undesirable situation, so it is going to lead to an increasing average cost curve. The elasticity of scale will be less than 1 here, and this is how we are able to connect the elasticity of scale with the shape of the average cost curve, and definitely the 3 phases that it has. So this was the topic of elasticity of cost, its relationship with elasticity of scale, and also the link between elasticity of scale and the shape of the average cost curve. Thank you.